Welcome to Programming with Professor Caleb. In the last video, we talked about some basic concepts regarding files and programming. Today, I want to concentrate on reading text files using the scanner class. Just like we use scanner to read character data coming from the keyboard, we can use it to read character data coming from a file. We start by creating a file object connected to the file we want to read. Here we create a file object for a file named data.txt. We can then create a scanner object just like we usually do, except that we attach the scanner to our file instead of to system.in. We can do both of those things in one statement. So this third statement, scanner input, is assigned new scanner, new file, data.txt, is exactly the same as the combination of the first two statements, except that we don't have a variable to keep track of the file, but we often don't need one. The tricky piece here is that we have to be prepared for exceptions. We'll go into more detail on this in a later video, but for right now, think of an exception as Java's way of telling the program that something has gone wrong. If you've done much programming along with these videos, you've seen exceptions like the null pointer exception or the array index out of bounds exception. Those exceptions are what we call unchecked exceptions. We can handle them and prevent the program from crashing, but they can occur pretty much anywhere, and we're not required to do anything about them. Opening a file for reading can cause a FileNotFoundException, which is an example of a checked exception. These are exceptions that occur in specific recognizable situations and that we are required to do something about. We have two approaches to handling the exception: the somewhat easy and not recommended approach, and a slightly more difficult but much better approach. The first option is to add a throws clause to the method that opens the file. This is pretty straightforward. We just add the words throws FileNotFoundException after the closing parenthesis of the parameter list. And then we add the same phrase to every method that calls this one, and every method that calls any of those methods, and so on all the way back to main. This also doesn't actually handle anything. If the file is not found where it should be, the program will crash with an error message, just as you've probably seen with other exceptions. Now, sometimes we need for the program to go ahead and end, though we can do it more gracefully. But sometimes we can recover from a missing file. Maybe we can start with the default information. Maybe we can ask the user for a different file name or a different file location. The good news is that we can do better with our second approach. The second approach is to use a try-catch statement. The basic concept here is that we put the code that might cause the exception inside a try statement, and then we have a catch statement for the exception. If we might generate different kinds of exceptions, we'll have a catch statement for each different type of exception. Here's an example try-catch for reading a file. Start with try, and then we have the scanner input is assigned new scanner, new file, data.txt, so that line to create the scanner attached to the file and open the file. Then whatever code we need to actually read the file, and then we close the file. And all of that is inside this try statement. Then we have the catch statement that specifies that we're catching a FileNotFoundException. And this code will get executed if and only if the code above generates the file not found. If everything goes well, we'll work through all the code in the try statement and skip over the catch and go on. If we get the exception, so the file isn't found and we generate that file not found exception, then we'll stop going through the code in the try and we'll jump into the catch and do that, which simply prints an error message saying, hey, we couldn't find the file you were looking for, and exits the program with a 1, because a 1 is an indication that there is a problem of some kind with the program. Now that we've actually opened the file, we need to read the data. This is where the scanner makes our lives easy. The same methods that we use when reading from the keyboard work with our files. So we can read line by line or word by word. If we know that our file has numbers, we can read those directly with nextInt or nextDouble. We usually want to use some kind of loop to read the whole file. We often don't even know up front how much data is in our file. The scanner class helps us out with that by providing a set of predicates that check to see whether there is another word, has next, or another line, has next line, or another integer with has next int, or another double, has next double, and so on. Note that we mostly use has next or has next line when just figuring out whether there is more to read, depending on whether we're reading item by item or line by line. We use the others more to check for correct data format, making sure that the next item actually is an int before we try to read it as an int. Given these predicates, it becomes very easy to read until the end of a file. Here are a couple of example loops for reading a whole file. So if we're reading line by line, we might say while input.hasNextLine. Then we're going to use input.nextLine to actually read the line and do something, presumably, with what we just read. If we're reading item by item, say we have a file full of numbers, then we might have something like while input.hasNext, my int is assigned input.nextInt, and then of course we're presumably going to do something with my int. One last thing we should always do with files is close them, as discussed in the previous video. This is very simple to do. Scanner has a close method that we simply call when we're finished with the file. Thanks for watching. In the next video, I'll talk about how to write two text files, and we'll do a demo.